Welcome back to question 35. All right, so here we go. Another solving rational equation. Let's do the same thing we did before. So very first step, well, I don't have anything to factor in here. So all my denominators, I actually only have one denominator of that x right here. So the only one I have to be careful of dividing by 0. So the only value I have to exclude, if I get it, is x is not allowed to be 0 here. So I'll keep that in the back of my head as I solve this. And if I get a 0 in the end, that will be an extraneous solution. So this one's pretty easy to pick out the LCM because these ones, you don't have to write these, but I'm just kind of showing you that this denominator would be a 1 and so would that. I definitely don't need to have that, all right? But I just don't have to worry about, picking out an LCM for those ones. I only have to think about what's going to cross cancel with that x. So the LCM is pretty easy to pick out here. All I need is an x. So I'm going to go through the whole equation. I was smart this time when I laid out the problem ahead of time. I left a little spot so I can put my LCM over there. I'm going to go through the entire thing. So this LCM has to go here, it has to go here, and it has to go here, right? So this one you might not need to do the same thing I did in the other one, but I'll still do it to show you that I have to do the x times the x. This is just a nice little way to organize your work so that you can really see what each thing cancels to. I had to do the x times the 1 over x. And I have to do the x times the 2. Okay, so on this one, not a ton cancels, right? I end up with, okay, so in the first one, those don't cancel because they're both in the numerator. So that gives me an x squared. This one, we chose the LCM of an x because of this denominator. So those do cancel out to 1, and I get 1 times the 1 that was already there. And then nothing cancels on the next one. X times 2 is just my 2x, since that didn't have any denominator to begin with. So these three terms are what's going to make up my new equation. Now watch what kind of equation I have here. All right, so my first term is x squared. Then I'm going to bring down the plus. My second term became a 1. I'm bringing down the equal sign. And my last term became a 2x. So the original equation up here was a rational equation. And the equation I have here now is not rational, right? So we changed the format of the equation, and that's why we have to check for extraneous solutions. So what kind of equation is this one? Now, the one we did on the same page, but on number 34, our new equation was linear, so we solved it accordingly. But this one right here is a quadratic. Okay, so I have to solve quadratics differently. So when I solve a quadratic, I want everything on one side to get one side to be 0, and then we're going to choose between factoring and the quadratic formula once we see what we have here. So I'm going to bring over the 2x. I'm going to put it actually right in the middle because no matter what method we choose, we like to have it as our quadratic term, and then our linear term, and then our constant. Let me just draw a little line here so we can keep those separate. So at this point, when we've got it all on one side, and we've got one side to be equal 0, we have to choose between factoring or quadratic formula. Now, you'll always get me to factor if I can, because it's so much faster. You could use the quadratic formula always at this point, but this one does factor. So and I can see that pretty easily. When there's a 1 leading coefficient, it's easy to kind of go through the combinations in your head and see what works, if anything. So this one is pretty easy to see that I can have x and x, 1 and 1, because those multiply to 1, and they'll combine to -2 if I do that. So that's factored, and then I'm going to set each factor to 0. And then, so now I'm going to solve each one. I end up getting the same answer. So every quadratic has 2 solutions, right? But they won't always be unique. Like here, I did get 2 solutions. I got 1 twice, but it's not a unique solution. So I really just got 1. So I'm double checking with what we said in the beginning. X is not allowed to be 0, and we didn't get a 0. So this is a valid solution. So we might put it in set notation. We could circle the 1, right? We can just say that this is valid just to make sure we show that it was not extraneous, that we did check it with the original to make sure it did not make any of our denominators 0. Okay, so we've got one more to do on the same page 36, so join me for the next video.